Center for Fearless Behavior Change, which is co-sponsoring the session with the Science of Behavior Change initiative. Today we have a former professor of mine from the NIH Summer Institute for Randomized Behavioral Clinical Trials. He's now the program director for that Summer Institute. It's Dr. Ken Freedland, who's the professor of psychiatry and psychology at Washington University. He's also the editor of the journal Health Psychology, among many other roles. And we wanted to make sure that this audience knew that there still is a plans for the NIH Summer Institute on randomized behavioral clinical trials to take place in the summer, although details are still being figured out, like all of us in the rest of our worlds. But please keep an eye on the submission deadlines for that, for those of you who have faculty or mentees that would be interested in joining. And otherwise, I'm going to pass the baton to Ken, and just my final words is to let everybody know, please feel free to use the chat function for questions. We'll collect them and save them for the end of end of his presentation, and then I will moderate a discussion around those questions. Ken, thank you again for joining us, and I'll have you take it from here.
Ian, thank you very much for inviting me. This is a topic that I'm very enthusiastic about, and glad to have the opportunity to speak to your group today. Don't have anything particularly relevant to disclose. So why am I talking about pilot studies? The problems that I'm focusing on in this talk come up very often in grant applications and study section meetings, in manuscript reviews, and in mentorship and training activities, including in the Summer Institute. And it's a problem that just really needs some attention, I think. My talk is based on a paper that has just been published in Health Psychology. And some of the things that I can't go into enough detail on in a talk, hopefully you'll have a chance to look at in more detail in the paper. So in many different areas of intervention research, pilot studies have traditionally served as what are known as preliminary efficacy trials, which for brevity, I'll just call them PETs. And these are miniature trials that are intentionally underpowered, and usually severely underpowered, and they're much too small for the kinds of purposes that people try to make them serve. And I want to make it clear that I'm not talking about full-fledged randomized controlled trials that the investigators intended to be adequately powered, but they had problems with under-enrollment or with high attrition. That's not the issue here. I'm talking about studies that are deliberately underpowered. When people conduct preliminary efficacy trials, they often have disappointing efficacy results. And when they do, this can end further work on useless interventions, which is a good thing, I guess. But unfortunately, it can also end further work on promising ones. Effectively, when you're working on an innovative intervention, it can kill the baby in its crib. But when a preliminary efficacy trial has pleasing results, researchers often take that as a green light for proposing a larger efficacy trial. And they use the effect size that they got in their pilot study in the power analysis for their proposed trial. But one of the problems that people often run into is that the rationale for conducting an adequately powered randomized controlled trial after completing an inadequately powered one of the same intervention is often kind of slippery. Why are you doing this? Why did you do a little study and now you say I need to do a big study of the same thing? Is this confirmatory research? Is this a mere replication? Are you saying that the pilot trial doesn't really count? It's difficult to explain, and often reviewers either go along with the logic or they will dispute the logic, and this can lead to problems for applicants. There are some very serious drawbacks with this tradition, starting with the fact that only a very small proportion of published preliminary efficacy trials in any field have ever led to a full-fledged randomized controlled trial. I would say the figure is probably a lot less than 10%. There have been analyses of this in several fields, such as this 2018 paper by Desai, which looked at the orthopedic surgery literature. I wasn't really able to find any in behavioral medicine, so I conducted a little mini study of my own. I found in the year 2010 that there were 11 self-described randomized controlled pilot trials of health behavior interventions in the literature on smoking, diet, physical activity, or medication adherence. I picked 2010 to give people at least 10 years to go from publishing their pilot study to publishing a full-fledged randomized controlled trial. And I tracked down every possible lead on these trials, and I found that none of them have led so far to a published full-fledged randomized controlled trial after 10 years. And so this notion that, that what you're doing when you do this miniature underpowered trial followed by a larger, more adequate trial, the notion that that's replication is especially untenable if investigators don't even try to replicate their findings. There are a variety of reasons why people don't ever do the big trial. Funding is one of them, but there are other reasons as well. And the fact of the matter is, more often than not, there is no big trial after the little one. Also, positive results of a preliminary efficacy trial in no way guarantee that a larger trial is also going to yield positive results. Quite to the contrary, many small trials with positive results are followed by larger trials with negative results. And this is even true in areas of medical research in which their small trials are a lot larger than most of what we consider to be large trials. For example, in the area of research on heart failure medications, lots of times they conduct phase 2 trials of heart failure medications with hundreds of patients, and they get positive results and follow it up with a phase 3 multicenter trial with thousands of patients, and wind up either showing no benefit of the medication or even showing harm. And so for us to rely on studies of 20 or 30 or 40 patients and believing somehow that that is a predictor of good things to come, I think is just folly. So this bears on our mistaken belief that these little miniature studies leading to a bigger trial, that this is a way of doing confirmatory research. And to me, the real most serious problem is, despite these glaring weaknesses and the lack of replications, preliminary efficacy trials are often said in the papers that are reported on them to have important implications for clinical practice. And people make clinical claims or claims about public health importance, and they make recommendations for practice. And these claims often go unchallenged, especially if there's no bigger trial that's ever done that can maybe lead to a different kind of conclusion. And so this stuff enters the literature, and often people take it, seriously and cite it, and it winds up in books. Clinicians wind up talking about it. And so I would say that these little seemingly innocuous little studies aren't so innocent. They're positively destructive in our literature. They do more harm than good. And yet, despite all of that, I continue to encounter a lot of researchers, including both junior and senior folks, who still believe that pilot studies are supposed to serve as preliminary efficacy trials. And when you submit a grant proposal to do a full-fledged randomized trial, that your proposal either should or must include some positive data from a preliminary efficacy trial. And people still believe that it's a good thing to publish these studies, and that even if they're never followed up with a larger, more rigorous trial, that they add to rather than detract from the literature. They're also problematic for journal editors. One of the reasons being is that authors often ask for special dispensation, and their cover letters often go something like this: we're sending you a severely underpowered preliminary efficacy trial, but please take it seriously as if it were a full-fledged randomized controlled trial. And by the way, please give us a break. It's only a pilot study after all, so don't hold it to the same standards as you would a full-fledged RCT. So clearly, these self-contradictory kinds of requests are pretty difficult to go along with. So are there any alternatives to this tradition? Well, Helena Kramer and colleagues have written eloquently and repeatedly about why we shouldn't use the effect sizes from preliminary efficacy trials in our power analyses when we're proposing randomized controlled trials. And I want to point you, if you don't already know about it, to a classic and what I consider to be a profoundly important paper that Kramer and colleagues wrote. This is their paper on caution regarding the use of pilot studies to guide power calculation for study proposals. This sounds like a kind of dry technical paper, and in some ways it is. It's not an easy read, but the reason that it's a classic is that it not only points to an issue about power analysis, it challenges our some fundamental ideas that we traditionally have held about what we're doing in intervention research and why we're doing it and what we're trying to accomplish. You have to kind of read between the lines to get the full impact of this paper, but lots of us who initially read it kind of fell off our chairs when we grasped the import of what they were saying. And so if we're not supposed to use pilot studies as the effect size input into our power analysis, what are we supposed to do instead? And by the way, how can we convince study section reviewers to fund our grant proposals if we don't give them some pleasing preliminary efficacy trial data? What are we supposed to do? Well, Kramer and colleagues argue that instead of using the effect size from a pilot study, what we should do is define and justify and use what they call a threshold of clinical significance. And they define this as the smallest between group effect that would matter in some meaningful way. Now they focus in their paper on the clinical impact as being the guide as to what's meaningful, but there are other ways of looking at meaningfulness as well. For example, are you chasing an effect that's at least big enough to disturb clinical equipoise among experts in the field so that it would change the mind of people who are experts in the area of research that you're talking about? Is it big enough maybe to encourage further research or maybe lead you to want to do a bigger trial? This may be a different kind of a standard than how big an effect has to be in order to justify a change in clinical practice. So a lot depends on sort of what stage of research you're at or what you're trying to accomplish with the particular study you're working on at the moment. Other authorities, when they talk about this concept, they use different terms such as the minimum clinically important difference, MCID, or sometimes the minimum important difference. These all mean roughly the same thing. So what are we talking about here? So let's say I'm planning a hypothetical depression trial, and let's say these are the depression scores on some kind of questionnaire. And let's say I imagine that at baseline, the participants in my study are going to average around 18 or so, something like that. And I think I have some reason for believing that the groups are going to differ by this much at post-treatment, and that's my primary outcome occasion. What am I saying when I define a threshold of clinical significance? I'm saying that whatever I define it as being, that the difference between these two groups has to be at least this big in order to matter. And in whatever way I say that it has to matter, whether that's clinically or to foster further research or to test some sort of hypothesis or whatever, it's got to be at least that big to matter. And so mere statistical significance isn't enough. It's got to be at least that big. And this, again, one of the reasons why this is kind of a revolutionary idea is that makes us have to think about, well, why would an effect that's at least this large matter? It doesn't, any old difference isn't good enough. Statistical significance isn't good enough. Why does it have to be a certain size? And to whom does it have to matter? Who am I trying to speak to in doing this study? And why is it that anything less than an effect of that size, why would that not matter? Why would something smaller than that not be good enough? It makes us think harder about these really kind of difficult questions, and they're all the more difficult before you've done the trial. And this is the time when you really have to think about them, because this is the point when you have to define a TCS in order to propose the trial. So in general, pilot studies can't answer those kinds of questions, and their results are irrelevant for defining a threshold of clinical significance. Where do you get those TCS values from then? A variety of different places, potentially, depending on the nature of what you're studying. You might draw them from epidemiological or clinical research findings. You might draw on the long-term goals of your clinical research program. You might need to get some stakeholder or cost-effectiveness perspectives on what you're trying to accomplish. You might conduct a needs assessment. There are a variety of different ways to inform how big of an effect is big enough to matter. And again, what's meaningful and for whom may very well differ depending on what phase of research you're in and really why you're doing the study. So let me give you a very hypothetical, fictitious example of how a TCS might be informed by epidemiological findings. So let's say you want to intervene in some kind of behavioral risk marker, some sort of health behavior, let's say, adverse health behavior. And you want to make a certain amount of change in that health behavior. And the reason that you want to do that is because that health behavior has been linked to some kind of adverse outcome in some medical population. So let's say we're talking about depression in cardiac patients, which is the area that I've been working in for quite a while. And let's say that for one reason or another, I say, or I've come to think, or the tradition in my field is, well, you have to have a 10-point difference on this depression measure in order to be clinically significant. Now, is 10 points good enough? Is that really what you need? Well, let's look at what the epidemiology tells us. Here's two different possibilities. One is, we know from epidemiological research that the relationship between this risk marker, let's say it's depression and the risk of dying after having a heart attack, okay? Let's say that the relationship is kind of a weak one. That's on this line. Or let's say that the literature, the clinical studies or the epidemiological studies suggest that actually depression is a pretty powerful predictor of post-MI mortality. So two different possibilities from the epidemiological literature. Now, what are the consequences of a 10-point difference if I'm able to achieve it? Let's say that 70 is the baseline level, and let's say that, let's just assume that the people in the control group never get any better. They stay at 70 before and after. But the people in my intervention group, let's say I'm doing some kind of CBT or some kind of medication or something, let's say they improve 10 points by the end of treatment. Well, if I've got a weak relationship between depression and cardiac mortality, that is going to translate into hardly any difference in the event rate. In contrast, if the relationship between depression and cardiac mortality is pretty strong, a 10-point difference is actually going to create a several point difference in cardiac event rates potentially. Now this is, sort of idealistic based on projections from epidemiological data, but you can see that this 10-point difference in the outcome variable of your trial doesn't have the same meaning for a weak risk factor as for a strong one. Similarly, if you have a big whopping difference, if your intervention is really potent and you have a weak risk factor, you still don't get much bang for the buck. Maybe this is enough to make the whole thing worth doing, but maybe it's not really going to make much difference. Here, though, if this were the case, you would make a huge difference in cardiac outcomes by treating depression. The problem, of course, that you would run into in proposing such a thing is, well, who's going to believe, and why would they believe that you can make such a big difference in the behavioral risk marker? That seems kind of unlikely. So you're kind of stuck between what's plausible or realistic in terms of what you can do in changing the risk factors that we target versus how much of a difference you'd like to make in the distal clinically important outcomes that you hope to change. So what constitutes a clinically significant difference? Again, this may depend on why you're intervening. If the behavioral, psychosocial, or psychiatric target is a treatment-worthy problem in its own right, that's one thing. So let's say I'm treating depression in cardiac patients because depression makes people miserable, and it causes all kinds of problems with quality of life and functioning. So whether or not I'm able to make any difference in terms of improving mortality rates, I don't care. I just want to help people with their depression, just like I'd want to help anybody with their depression. If depression per se is the issue, then maybe a few points difference is enough to improve their functioning and quality of life or whatever. But if I'm treating depression because my goal is to reduce the incidence of coronary heart disease or to reduce the risk of rehospitalization or death in patients with established coronary heart disease, well, depending on that risk relationship, maybe I need to have a much bigger effect on depression. And so the threshold of clinical significance for depression, it may be the same for goals 1 and 2, or it may be quite different. And the fact is that a preliminary efficacy trial is not going to be any help in figuring that out. It's just not going to give you the information that you need. Now, Kramer et al. Also recommend a particular effect size index, which they call the success rate difference, to define the threshold of clinical significance for trials. They suggest that you use it in the power analysis for your trial proposal and also for between group comparisons. The nice thing about it is, even though very few of us have ever heard of this animal, it's convertible to more familiar and interpretable indices, including Cohen's d, hazard ratios, and number needed to treat. As shown in this table, so an SRD, let's say of 17 is comparable to a Cohen's d of 0.3, number needed to treat of 6, depending on what kind of risk you're studying, either a hazard ratio of 0.7 or of 1.4. So what is this? Now, conceptually, at least, if you take a randomly sampled patient from the treatment arm and another randomly sampled patient from the control arm, the one with the better outcome is the one who you call the successful patient. And the success rate difference is roughly equivalent to the probability of the treatment patient being the success minus the probability of the control patient being the success. So if every success is a treatment patient, then SRD equals 1. If every success is a control patient, it's -1. And if it's 50-50, then the SRD is 0. And so when you're planning a trial, you usually are hoping or expecting for an SRD that's somewhere between 0 and 1. And so by defining and justifying a TCS in your grant proposal, you're telling the reviewers that the efficacy effect size that you hope to observe is going to have to be at least that large for the results to have much of an impact. And you're promising essentially not to conclude that the intervention is efficacious unless the effect you obtain is as large or larger than the TCS. In other words, you're not going to claim efficacy merely on the basis of statistical significance. It's got to be big enough to cross that TCS threshold. And when you do that, the reviewers are going to have an answer for why do you think that you have a good chance of finding an effect that's at least that large? And how do you convince them of that without any preliminary efficacy data? In my perspective, what you have to do is persuade the reviewers that an effect that's at least as large as the TCS is a plausible outcome of the trial. Not a guaranteed outcome, but a plausible one. And again, pilot studies aren't really designed to make plausibility arguments because their logic doesn't lend themselves to it. You're basically saying when you do one of those kinds of studies is that, well, we found the effect in our little tiny study, ergo, we're going to find it again in our big study. That's not plausibility. That's kind of a false promise. Something's plausible if it seems truthful, reasonable, credible, believable. And asserting that an effect is a plausible outcome is quite different than claiming that it's basically a sure thing because you've already shown it before. I also would point out that the principle of equipoise, which is sort of a bedrock idea in the world of clinical trial research, suggests that it's unethical and pointless to conduct a trial if you really have no doubt about how it's going to turn out. And of course, the favorite example of this is if you randomize a bunch of skydivers to either a parachute or no parachute condition and compare mortality rates to prove that parachutes work. That's not a study that anybody would really want to do. Although this guy actually did jump out of a plane without a parachute intentionally, and he lived to tell the tale, which kind of is amazing. So preliminary data, the right kind of preliminary data, can't guarantee that a trial will turn out well, but it can suggest that a favorable outcome is at least plausible enough to be worth going ahead with the trial. Where do you get evidence of plausibility? One thing is, and I think this is important, it comes from the scientific credibility of the intervention. So if you have grounded your intervention in basic science and research is coming out of a translational or optimization framework, like the science of behavior change that many of you are involved in, or the orbit model, or the MOST framework, and that the intervention has gone through systematic development, testing, refinement, and so forth, that really lends credibility to the intervention as opposed to some of the pop culture kinds of inspirations for some of the treatments that people want to test, or they come up with some fancy theory and decide that having a theory is good enough to move ahead with developing and testing an intervention, even if it's all just sort of thought up. And also, the literature in our field is not rife with dramatic breakthroughs. Most of the progress that we ever make is incremental. We hope to do a little better than whatever the current state of the art is, if we're lucky. And so when you propose a threshold of clinical significance, hopefully what you're proposing is something that's marginally a little better than what we're already able to do, but not necessarily dramatically better. That's probably asking for too much. And reviewers are probably going to be skeptical if you claim that you're going to be able to do really dramatic things rather than just incrementally better than what's come before. But one of the most important sources of data would be from what are known as proof of concept studies. These are small uncontrolled trials and or multiple N of 1 trials. And again, I know your group has been very active in working on N of 1 trial methodology and how to use them in intervention development and preliminary testing. And that's a great thing, because that can be very, very hopeful. So here it is a key point, a take-home point. You've defined for your grant proposal a threshold of clinical significance on some reasonable basis that you've grounded in the literature, on your preliminary work, whatever. You say that the effect has got to be at least this big in order to be meaningful in whatever way you're saying meaningful has to mean. That's one thing you have to establish in the proposal. The other thing is you have to establish whether finding an effect that big is a plausible outcome of your trial. Do you have a chance in hell of finding an effect that big, or is it just seem futile? Because if everything that you've done in your preliminary work or everything in the literature suggests that it's really unlikely that you're going to get an effect that big, well, that's not going to go over well with the reviewers. Whereas if you are able to show that, hey, it is possible to get effects in the same neighborhood or maybe even a little bit bigger based on your own work or based maybe on similar interventions in the same population, or maybe based on different interventions in other populations, whatever you're using to build your argument, you need to say that really I'm not only claiming that I'm need to find this, but that I have a reasonable chance that I can find it. No guarantee, but there is a good possibility that I'll find it. And I'm in equipoise about it. I don't know for sure. If I knew for sure, I wouldn't be doing the study. But there's good reason to believe that the trial could turn out to find an effect at least that large. So in the orbit model, they recommend N of 1 trials, and they also recommend these kind of small sample uncontrolled open label trials as a way of getting proof of concept data. So this is one example from the literature where, based on an N of 4, this is 4 subjects. This is adherence to asthma inhalers in low SES inner city African-American teenagers. And their baseline level of adherence is practically 0. They simply don't use their inhalers in this population. And with the intervention that this group developed, they were able to get these kids, only 4 of them again, but get them to, in a sustainable way, to a level of over 70% adherence to their asthma inhaler. And that graph was enough to help this group get a proposal for a much larger trial of this intervention. Now, it's important to recognize that that target, let me go back here, this 70% threshold, that's a clinically significant target, and it didn't matter how far the kids had to go to get there. The key thing was that they got there, because in the clinical literature on asthma, 70% adherence to asthma inhaler is what the asthma specialists say is the minimum level of adherence that these kids need to keep them out of the emergency room. And so we're talking about a threshold level of adherence. And that target is a within-person threshold. So there are two different kinds of thresholds you might be looking at. One is a naturalistic one, like remission, let's say. Another is an artificial dichotomy, like 70% adherence, where you're chopping up a continuous variable. And that, of course, can raise some statistical issues, but they're both useful. Either way, you're defining achievement of that category, the remission or above 70% adherence. That's success in this framework. Anything less than that is not a success. And it's important to recognize that clinically significant change within persons is not the same as clinically significant differences between groups. A lot of people get stuck on this and confused about it. So the amount of change that a person makes is not the question when you're proposing an RCT. And also whether an individual crosses that threshold, that's not really the question. The question is, how big is the difference between the treatment groups? So how do you get from this within-person perspective, from your proof of concept work, to the between-group perspective of an RCT? The way I would propose doing it is to move to considering the percentages of people in the treatment versus the comparison condition who reach that threshold. In other words, kind of like what Kramer et al. Were talking about, how many successes are you getting in the treatment condition versus how many successes are you getting in the control condition? And when you do that with artificial categorization, you may still need, for statistical reasons, to use the continuous score, like the continuous adherence score, as the primary outcome measure. You may need that for statistical reasons, but you will want to use this success dichotomy at least as a secondary outcome. There are no norms that I know of for how many successful examples you need to show in your proof of concept stage for behavioral interventions. Like I said, this group in 2008 had only 4 examples in their graph, and yet that helped to convince the grant reviewers to fund their trial. So let's say your proof of concept work has 10 patients and only 2 are successful, 8 aren't. Is that good enough? As a reviewer, it really, would give me some pause. What about treating 10 patients and you get 6 successes? Yeah, maybe. I mean, that's not so bad. Other people may think differently. Who knows? What if you treat 10 patients and 8 are successful? More convincing? Yeah. Of course, this is a small sample. Of course, there may be sampling biases. Of course, you may be cherry picking. There's all kinds of problems with this. But this, again, is preliminary data. You're trying to build the case that, hey, this intervention actually gets people to a place where historically or in clinical practice, we rarely see them get. That's all you're trying to say here. As long as you're transparent about how many failures you have, transparent about the sampling, then it's okay and really very helpful to use this kind of data. Also, feasibility is an important question. Getting an effect as large as the threshold of clinical significance isn't going to seem plausible to reviewers unless you can persuade them that the trial is well designed, it's going to be rigorously conducted, and that it's feasible. And when you look at the consort extension for feasibility in pilot trials, the aims of pilot trials are entirely or primarily about the feasibility of a planned, full-fledged randomized controlled trials. A pilot trial is a special type of feasibility study. What's special about it is it has the same design as the planned trial that you're planning to propose, the big trial. And of course, it's only possible to do that kind of a pilot study if you've already decided on the design of the big trial. And when you propose the pilot study, you better, in your pilot study grant proposal, have a section that talks about that big trial that you're aspiring to do, so that the reviewers can say, this pilot work that you're doing is in the service of getting you to this bigger trial. And they can read at least a paragraph or two about that bigger trial to know what it is that you have in mind. And also, the consort concept of feasibility, again, is about the feasibility of a planned or proposed RCT. It's not about the feasibility of the intervention. I see this all the time, where people think that a feasibility study means that you're talking about the, quote, feasibility of the intervention. Well, you know, the acceptability of the intervention to patients, issues about training and delivery and fidelity and all that kind of stuff, those are important, and they're important aspects of feasibility, but they're not the only ones. For instance, the feasibility of whether you're going to be able to recruit, randomize, assess, retain, those are all really important issues in planning a trial and establishing whether the trial is going to be feasible. And so if you're doing a preliminary study that's primarily about the intervention, like is it acceptable to patients, or can you train therapists to do it well? If it's mostly about the intervention, call it an intervention development or refinement study, or something else from one of these translational models, like a dose finding study, let's say. Reserve the term feasibility study or pilot trial for studies that really fit the consort definitions. I think we'll all be better off if we start trying to do that. Now, one of the problems that people have is that feasibility study aims are pragmatic and mundane, and applicants often worry about just limiting their proposal to such mundane kinds of aims. Is it going to hurt you? It might. Maybe you want to dress up your proposal with something a little more interesting, but you got to be careful about how you do that, because sometimes you wind up with aims that on further reflection may not be fully compatible with one another. But also bear in mind that there are some R34 funding mechanisms that require that whatever you're going to do has to be necessary and sufficient for your ability to go ahead with the application for the big trial. So in other words, that study has to be the last one that you do before you move ahead and propose the big trial. There is a nice tutorial out there in the literature on how to do feasibility studies, and I recommend it. I have the references at the end of the talk. So how do you make the case for a big trial? You define the threshold of clinical significance, convince the reviewers that it's well chosen, that it would be worth finding, given everything that you know and are able to talk about in the proposal. Convince the reviewers that it's plausible, that you have a reasonably good chance of finding an effect, at least that large, that it's more than just wishful thinking. If you do a proper pilot study, like they say in the consort guidelines, they're very, very valuable in many cases, but they're not going to help you define the threshold of clinical significance. They're not going to give you much of the evidence you need to support your plausibility argument, and you shouldn't use them to provide preliminary efficacy data. Now, again, one of the reasons that we keep seeing preliminary efficacy trials is that many people haven't gotten the message that there's a lot of other kinds of preliminary studies. And these translational research frameworks and optimization frameworks, like the science of behavior change and MOST and ORBIT and others, they've opened the door to many different kinds of preliminary sorts of studies on behavioral interventions. We don't just have one kind of study to do, and that everything has to be wrapped up in that one preliminary study before you move on to a trial. You can do a whole program of preliminary research and go back and forth to different stages or phases until you're really ready to do that big trial. Now, the fact is, some grant reviewers know about all of this and others don't. And you may submit a grant proposal with the best of intentions, and based on what I and other people say, you may not give the reviewers a preliminary efficacy trial result, and they may want, encourage, or even expect you to give that to them. And so maybe you argue, especially on the first round, maybe you have to cave in, but there's only so far you can go. And so to quote an old song by Kenny Rogers, you've got to know when to hold them, know when to fold them, know when to walk away, and know when to run. So to minimize the number of times when we all have to run, I'd like to ask you to please help educate fellow reviewers, colleagues, and trainees that preliminary efficacy trials are obsolete and counterproductive, and also that there are a lot better alternatives available to us nowadays. Again, there are references. I'd be happy to provide this in the form of a handout if you need. And with that, I will stop, and I'd be happy to answer any questions.
And thank you so much. I've heard different parts of this talk at different times, but each time I definitely feel like I learn it in a deeper way. And, you know, definitely with our Roybal Center, we are, you know, it's really focused on these early stage development of interventions. And we've been thinking about where are we? What is the best use of our resources? Is it a proof of concept study? Are we ready even to go towards pilot randomized trial? And yeah, thank you so much for sharing this presentation with us. There are a few questions that we got from the audience that I was going to ask you to comment on. The first one, I think, comes out of the reproducibility crisis that we hear sometimes in the field of psychology, but of course it applies to all, if possibly all of science. And that's, how do you balance this notion of coming up with the TCS with the fact that there's also these concerns about being, you know, when you get to your big trial, that we're still, you know, we're still underpowered and our confidence intervals are too broad, and then we don't get to reproducible sample sizes. So how would you integrate that concern into how you would estimate your sample size for the larger trials?
Yeah, that's a really important question. I failed to mention, and I want to make it clear, the statisticians with whom I've discussed all of this do say that it's possible to use data from relatively small pilot studies to inform the variability estimates for power analyses. What they don't want you to do is to use between group effect sizes and plug those in as though that was the proper effect size to use in your power analysis. One of the reasons is, again, the reproducibility problem. There's an sort of a publication or a selection bias. We tend to focus in on the ones that turn out well, these preliminary studies, and we sweep the ones that don't turn out well under the rug. So as Kramer et al. Point out in their classic paper, this leads to one of two possible outcomes. Either the big trial never even gets proposed, or it does get proposed and it's grossly underpowered. because you've overestimated the effect size. Now, I would add one of the really startling things about Kramer's approach is that not only is the effect size from the pilot study questionably reproducible and maybe over-optimistic, but it's the wrong effect size. When they talk about the threshold of clinical significance, they're compelling us to think about what we are doing and why we're doing it. Why does it matter? Why is it big enough? Why is anything less than that not big enough? That's not something that we're just plucking out of a small study and saying, well, we found a 3-point difference here, therefore I should go find a 3-point difference. And it's quite different really than saying, well, in my area of research, everybody's always found a 4-point difference. And so therefore that's what's clinically significant. I should go find a 4-point difference. Why is that meaningful? And as a matter of fact, if we keep doing that over and over again, what we keep doing is entrenching the status quo even further, right? Why do we want to keep doing trials in order to prove that we aren't any better off than we were 10 or 20 years ago? We want to do trials that in some way move the ball a little bit. And so what is moving the ball? If nowadays we're only, despite our best efforts, let's say we could only make a 3-point difference in depression, and people don't feel better when they only make a 3-point difference in depression. How much more of a difference do I have to make for them to feel better or to function better or to be able to go back to work or whatever the hell it is that I'm chasing? How do I learn that? How do I figure that out? That's the difference that you power it around. It's not a matter of reproducing that difference from some small study. And it's not a matter of doing a big trial that's too small to really test it. Your big trial should be big enough to detect an effect that's as large or larger as whatever you say the TCS is. And if it is that big, then if you get statistically significant results, they will also be clinically significant. So it's really a win-win.
Thank you. So I have another question. You mentioned earlier that these trials that are sort of misadvertised as pilot efficacy trials can become pests and they can infest our literature. And as someone who does a fair amount of meta-analyses or systematic reviews, I'm wondering, what do you think about what if there were lots of small pilot efficacy trials? Can you pull them together? Should there be some criteria with excluding them from meta-analyses? And if so, how would you make that determination? Is there a bare minimum number of subjects, or how would you think about that?
Well, those are excellent questions. I ask them myself because I'm not an expert on meta-analysis. I think different meta-analysts disagree on this point to some degree. And I would mainly want to say that regardless of whether it's mathematically and statistically okay to pool small studies or to throw them in with bigger studies, the big problem that I see with it is lending them credence by including them in meta-analyses. It's what people say about them. They're there in the literature, they get amplified by getting included in meta-analyses. And so this problem of people drawing clinically important conclusions based on them, it's only aggravated by including them in meta-analyses. Now that's all aside from whether it's a good idea or not in terms of assessing the literature. And I'm really not qualified, I don't feel, to comment on that. It may be a good idea in terms of characterizing the literature, or it may not. But I think if those studies are included in meta-analyses, I think that the analysts have to go to some length to say, hey, beware of making too much out of these small studies, especially if they were never followed up by bigger ones. And just be cautious about that.
Great. So I have one other question. So you mentioned the idea of using, single patient trials, or, having a few subjects go through and really looking through to see if they cross a therapeutic threshold. Myself and some other people in our group have done some N-of-1 trials, and one of the ones we did had to do with trialing light therapy. It was with a bright white light, or what we thought was going to be like a sham of a dim red light. And we found there actually was a lot of one of the purposes of N-of-1 trials is to help figure out whether there's a lot of heterogeneity between how individual patients benefit from an intervention, with the idea that some people have benefits, some harm, and maybe we can start doing precision therapy that way.
Yeah.
And so I'm just wondering if we're using, a small number of N-of-1 trials to help understand the plausibility of an intervention, what would we do when we start seeing a lot of variability in this sort of small sample of patients?
Well, one of the interesting things about trials is they're about group averages. Whether or not you're talking about precision medicine, lots of us in our field seem to be enamored of moderator hypotheses and maybe subgroup analyses. But when you think about it, if you really think that there is a big moderator, a powerful moderator of your treatment effect, or if there are subgroups buried in your population that don't benefit much from whatever it is that you're doing, maybe you're doing the wrong trial. Maybe you're testing an intervention on a large group of people that only you suspect up front that only some are going to benefit from. That's going to hurt your average difference. So maybe before going into a trial where you're banking on averages between groups, knowing that there's a chance of an important moderator or subgrouping, or maybe that's something to work out in advance. Maybe some kind of stratification, or maybe working out that there's a different approach for that group than this group, and that you're not going to lump them all together and throw the same intervention at them. So I think those N-of-1 trials can really put you on a great path for doing the kind of work that's needed before you ever get to a big trial where you're kind of shooting yourself in the foot with heterogeneity.
That's a great way of thinking about it. Just one final question. I'm just curious, based on your own direct experiences or talking to other people, this is more from the perspective of the gamesmanship, the Kenny Rogers. Do you have a sense as to the extent to which these ideas are taking hold in sort of NIH grant reviews? Do you feel like from 2006 to 2020, do you feel like reviewers are less looking for that that pilot efficacy trial, and they're more sort of understanding the proper role of pilot studies?
From the study section that I'm on, and we specialize in clinical trial proposals and R34 proposals. From that, and from what I hear from other study sections, I'd give it a very mixed review at this point. Back in the day, 2008, 2009, nobody knew about this stuff. It was brand new, and was uncommon to find anybody who really had any idea about it. More and more, especially the more methodologically sophisticated reviewers, this has really become clearer to a lot of people. But there's still plenty of people in a variety of different disciplines where it's just assumed. It's like common knowledge. Of course you do a preliminary efficacy trial. Why wouldn't you?
Right.
So it hasn't penetrated yet enough that you can bank on it. You really need to make the argument and cite some of these sources. And I always try to caution people, even if what I'm saying makes some sense to you, don't assume that the reviewers of your grant proposal are going to see it the same way that I do. Maybe I'm right, maybe I'm wrong, but don't bank on other people necessarily having the same kind of perspective that you've just heard about. So you've got to build the case yourself, basically.
Thank you. So I think we're pretty much out of time. Again, Ken, thank you so much for joining us today. For those of you who joined late or want to hear this talk again and share it with your colleagues, this will be saved on the Science of Behavior Change website, which is scienceofbehaviorchange.org. We'll also include it on our Roybal Center website, which is the Columbia Roybal Center for Fearless Behavior Change. And just a pitch for those of you who want to hear another excellent speaker, Dr. Lisa Marsh will be joining us. It's also a co-presentation of the SOBC and Roybal Centers, presented on Tuesday, October 27th at 1 o'clock. So please join us then, and we look forward to seeing all of you again soon.
Thanks, Ian. Thanks, everybody.